Imagine you need to send a crystal clear 4K video across a distance of 6 miles. No glitches, no signal drops, no lag. How does the broadcast industry actually pull that off?
Uh, Well, it requires an incredibly specialized, completely invisible infrastructure.
Right, and today our deep dive is looking at exactly that. We are decoding a product code from HDTVSupply for the AJA FiDO-R-12G-ST.
That is a mouthful of a name.
It really is. It's a 4-channel 3G SDI to single-mode SD fiber transmitter. And our mission today is to figure out how this specific gear solves massive data transmission problems for live video.
Yeah, so let's start with what it actually does, because it essentially acts as a bridge. Professional video relies on SDI, or
Yeah.
serial digital interface.
Okay.
And SDI pushes raw, uncompressed video, which demands a huge amount of bandwidth.
Oh, for sure. Like a heavy 4-lane highway of raw data.
Exactly. So this device takes 4 independent channels of that heavy SDI data and turns it into optical fiber signals.
Wait, so we're taking a pristine, uncompressed video signal and basically turning it into flashlight pulses.
Yeah, pretty much.
It's like taking 4 separate conversations happening through tin cans and string and translating them all into a single high-speed bullet train of Morse code flashes.
That is a great way to picture it, actually.
But doesn't doing that risk losing all the complex metadata? I mean, like high dynamic range?
You'd think so, yeah.
Yeah.
But that is exactly the engineering feat here. It doesn't just send the raw pixels. It flawlessly passes through that crucial SDI metadata.
Oh, wow. Really?
Right, so the HDR, those really bright highlights and deep shadows, it all remains perfectly intact while being beamed as light.
Okay, but if translating the data is that complex, why go through the hassle of converting it to fiber at all? I mean, why not just stick to standard copper cables?
That is a completely fair question.
Because copper is cheap, it's everywhere, and you don't need some expensive translator box, right?
Well, it really comes down to the strict laws of physics. Copper wires use electricity, meaning they have physical resistance.
Right, the signal degrades over distance.
Yeah. Exactly.
Yeah.
The longer the wire, the more your video signal fights that resistance until it just dies, usually after a few hundred feet.
Ah, okay.
But fiber uses light inside glass. There's zero electrical resistance. That allows this transmitter to push a signal up to 10 kilometers.
Wait, over 6 miles?
Yep, over 6 miles.
So you could run a cable across an entire city or like a massive sports stadium with zero signal loss?
Exactly. And because fiber uses photons instead of electrons, you get a second massive advantage. It is physically immune to electrical interference.
Oh, because anyone working with traditional copper knows all about ground loops.
Oh yeah, ground loops are a total nightmare.
Where electrical mismatches introduce a nasty buzz or those rolling visual bars right into your feed.
Right, but because this device uses a specific 13410 nanometer wavelength of light, those electrical issues simply cease to exist.
Light doesn't care about a bad electrical ground.
Exactly, it just works.
So if light allows us to push a flawless signal 6 miles without any electrical interference, the hardware generating that laser beam must be massive.
You would definitely think so.
But looking at the specs, I mean, it's a tiny box, it's less than an inch thick, weighs under a pound, and draws just 5 watts of power.
And yet it costs almost $2,000.
Right. You might be wondering why anyone would pay nearly $2,000 for a box smaller than a paperback book that just, converts cables.
Well, that footprint is highly deliberate. You are really paying for that extreme miniaturization.
Because in high-end broadcast environments, physical space is incredibly precious.
Oh, absolutely. This transmitter is engineered to squeeze into unbelievably tight spaces.
Like tucked behind packed equipment racks.
Yeah, or jammed inside crowded broadcast trucks.
Oops.
You can even mount it directly onto a moving camera rig. It has to do all that heavy lifting without getting in the way.
It really highlights the hidden infrastructure of high-end video production, doesn't it? We just sit back and watch the screen.
Completely unaware of the insane engineering required to guarantee flawless delivery.
Yeah, it really is the invisible backbone of modern broadcasting.
Definitely. It was what makes it all possible.
So next time you watch a live event with perfect HDR video, just think about the invisible 1310 nanometer light pulsing through miles of fiber optic cables.
Yeah, all powered by a silent 5-watt box, smaller than a paperback book.
It really makes you wonder what the next bottleneck will be, because as we push toward 8K resolution and beyond, our ability to broadcast reality live might rely less on building better camera lenses and more on how efficiently we can turn reality into a beam of light.